Okay, well, I see that it is 8 o'clock, so we are going to kick off. Good morning, everyone, and welcome to today's edition in the monthly series of collaboration and knowledge sharing webinars presented by the Alberta-India Chamber of Commerce. My name is Anoshka Fernandez, and I'm proud to be a strategic advisor within the AICC's executive team and the moderator for today's session. We are very grateful for the overwhelming response we have received since the launch of our chapter formally in August of this year. This morning, we have invited key leaders in the carbon capture and storage subsector to come and share their experiences with us on this important topic so we can start some thinking by business leaders in both Alberta and India about how we can build greater collaboration between our jurisdictions in this important sector. Today's webinar is the second of the three series that we have focused on the energy sector, specifically designed to increase conversations in the lead up to India Energy Week at the end of January 2026. Hosted in Goa, the Alberta-India Chamber of Commerce is excited to announce that 4 months into our existence, we are an official partner of the Government of Alberta delegation to this important trade exhibition. To view our past webinars, I encourage you to visit the Alberta-India Chamber of Commerce YouTube site, and a link to that channel has just been placed into the chat. You'll be able to look at all of the webinars that we have done since we started this series in September. We have 60 minutes scheduled for this morning's chat, and we're eager to hear from many speakers. So I'm just going to quickly outline some ground rules for the benefit of everyone that's participating here. First of all participants have been muted by our host. Questions can be inputted into the chat feature at any time, and I will do my best to get through all of them at the end of the session. To keep things moving, we will be introducing each speaker directly through me. And we have allotted each speaker 7 minutes to speak. They will receive a pop-up warning privately on their screen when they've got 2 minutes left. And when there is only 1 minute remaining in their time, my face is going to pop back up alongside them on the screen as another visual cue to please wrap up. So we thank all of our speakers in advance for their cooperation with this protocol so we can stay on track and make sure that everyone gets a chance to make their points. With that, I'd now like to introduce the President of Alberta Operations, Mr. Anupam Srivastav. Anu, the floor is yours.
Thank you, Anoshka, and good morning to everyone here, and good evening, people for joining from India in different time zones. First of all, welcome again to yet another great webinar on energy. And this word energy has changed its meaning and form for me particularly, and I bring the greetings as well from our India team, Dr. Vanda Srivastava, the president of the India chapter, who is on the screen, I can see. So greetings from both the sides to all of you, and also welcoming all the distinguished guests today. You've been thoughtfully chosen and picked to be one of the speakers just because we all are preparing for the India Energy Week, which is to be held in Goa. And we have proudly collaborated with the government of Alberta, and we will be representing, and so would some of our fellow members from here, strongly encourage a lot of people who are yet not members and maybe thinking about this is time to really join our hands either on this side or on the India side to strengthen the relationship between Alberta and India in terms of bilateral trade and commerce and culture and traditions and all that. With that said, I would really not be between you and the speakers. I would give it back to Anoshka. Welcome again. I'm really looking forward to really hearing a lot on the carbon capture today. I mean, this is a great topic. Carbon certainly has been on the top of the minds, and the carbon neutrality, which has become a fashion word all across the globe. I'm really looking forward to listening to a lot of the great speakers on that subject. Anoshka?
Great. Thank you so much, Anupam. So let's get to our speakers. Our first speaker today is Mr. Kishore Kumar Bimwal. Our chamber has been very grateful for the ongoing support of the Government of India through the consulate in Vancouver. And so we are quite excited for Mr. Bimwal's presence today, as he is the first speaker we have had in our webinar series from a Government of India ministry. Mr. Bimwal is currently serving as the Additional Director for the Centre for High Technology, with the Ministry of Petroleum and Natural Gas. He is involved in green hydrogen, renewable energy projects, and e-fuels policy. Currently, he is handling Site 2B scheme, overseeing the procurement of green hydrogen by oil marketing companies on a build-to-own and operate basis. Welcome to the webinar, Mr. Bimal. The floor is now yours.
Yeah, thank you, Anushka. Hope I'm audible.
Yes, very good.
Yeah. So thank you, Anushka, for nice introduction and inviting me here for this webinar. Good evening and good morning to everyone. My name is Kishore Kumar Bhimal. I'm Additional Director in CST. So it is a great honor to address this esteemed forum today on a topic that is absolutely vital for India's future, which is CCUS. Why CCUS is crucial for India? CCUS can be instrumental in decarbonizing our industries and achieving our NDCs. Our net zero target is 2070. So solar and wind power, it is playing its crucial role in this energy transition. But we have to be realistic. Our economy is growing very fast, and for a longer time we have to rely on this fossil fuel like coal, crude and gas to keep our energy running, and we are aware of this fact. In this context, I can say that CCUS is not just an idea, it is a crucial technology to deeply cut our emissions from hard to abate sectors. By using CCUS, we can also significantly, bring down the overall cost of our energy transition and keep our existing plants and factories running. And understanding the importance of CCUS, India is in the final stage of developing its own CCUS policy. The Ministry of Power is leading this national effort. With some reference, some of the report says that India needs 5 to 10 gigaton of CO2 capture by 2050 to meet its global goal of limiting temperature to 1.5 degrees C. This brings up a fundamental question in our mind, that do we have enough storage space deep underground to store the CO2? So the answer is yes. India is currently the third largest CO2 emitter with the capacity of 2.8 gigaton per annum, and this is going to rise by 4 gigaton by 2030. So globally the world needs to capture over 1.2 gigaton of CO2 annually by 2030, but the current operational capacities are very less. So in this context, I can say that the 4.5 or 4 or 5% only we can utilize the capture CO2. We can utilize ultimately 90 to 95% we have to sequester. And unlike other countries, India don't have that depleted oil reservoirs. So the answer is in India's vast underground solution. Based on the detailed reports, the total theoretical underground CO2 storage potential in India is roughly say 650 gigaton. And this capacity, which is spread across four major geological areas, includes deep saline formations, basalt formations, the oil and gas reservoirs, and the last one is coal fields. So I want to highlight the basalt, that basalts will be the game changer in India's space for this CCUS. We possess one of the world's largest area of basalt rock formation, rock on land. Talking about the technical brilliance of this basalt is in its storage method, which called mineralization. Instead of simply trapping CO2 into rock pores, like storing air in a sponge, injecting it into basalt causes a chemical reaction that turns the CO2 into stable, let's say permanent salt, means turning the CO2 into the rocks. So this offers two major benefits. Number one is zero leakage risk, and number two is lower monitoring cost. However, this is a new territory, and we urgently need dedicated national research to map India's deep basalt and understand how quickly this mineralization process may happen. That we have to understand. So while 650 gigaton, it is a fantastic theoretical number, we must face reality, and the storage sites are deep underground. But what's above them, it is matter, like farmland, forest, rivers, and crowded cities. When we factor in this constraint, the theoretical potential of this 650 gigaton drops into a realistic storage potential of 100 gigaton. So the real challenge is not a lack of geological, but overcoming this big hurdle to safely unlocking this space. Huge investment, legal issues, and public concerns are the major challenge for us. Despite these roadblocks, real world projects are already validating CCUS system within India. Many of the oil and gas companies, and they are working on utilization part, like in Tuticorin TFL is successfully capturing the CO2 and utilizing for the valuable soda ash. So, and Oil India, it is working for CO2 enhanced oil recovery for their Naharkati and Dicom fields, and other refineries they are also doing. So my point and the way forward is, for this CCUS transition, we need a clear and a two-step plan. Number one is immediate focus. We need to start large commercial projects by injecting CO2 into oil and gas fields for enhanced oil recovery. This is number one. And this uses existing data and gives companies a way to earn money immediately. And number two is critical focus, which is next 5 years are essential for aggressive, dedicated R&D to map and prove this massive potential in basalt, deep saline formations. That is quite very important. And my closing remark, I can say that India has more than enough underground capacity to meet its a climate goal or demand for the CCUS. And I'm pretty sure that CCUS will play its critical role in decarbonizing industries and achieving our NDCs. So likewise in green hydrogen and other facets, CCUS is going to be a game changer for India. That's it. Thank you.
Okay, thank you so much, Mr. Amal. It's really great to have that overview. Appreciate it very much. Our next speaker is Mr. Kishan Patel, and I believe he has signed in under a different name. So, Mr. Patel, just want to confirm that you are on the line. Kushal, can we get him unmuted, please?
Yeah, I'm good.
There you are. Okay. So welcome to the webinar. Mr. Kishal is the owner of Akshar Enterprise. So please go ahead, sir. The floor is yours.
Yeah. Ma'am, my name is Kishan Patel and I'm working since 1999 in solar industries. Not except only solar industries, but we are working in, we are working like a Jewish people, like a big peoples, what they are doing, like China. They are making hub. But we are working engineering, electronics, electrical. We connect every points together. But my main aim is to save climates in my India and completely dominate my all research to society at a very economical price. Right? Second thing, innovative. When we innovate anything, like in the solar industry, we innovate road blocks, solar tiles. Thereafter, when we innovate road blocks, at that time we connect lot of alternative electricity together. Like only solar we cannot use in a commercially, but when we connect different type of alternate electricity, connect with the solar. Not only wind is costly, but so piezo electricity, green hydrogen, and thereafter there are two types of solars. One is off grid, second is on grid. So when we connect all the alternative electricity, piezo, wind, green hydrogen, and some industrial parts, we are directly using DC current to our chemical industries. So solar is a big part in my research, and we developed solar roadblocks. It's my very future, very. It's a future because what happens? Lastly, we go in green hydrogen and electricity, right? So what happens? So if we use roadblocks, then we connect lot of highways, lot of outdoor out areas. So what happens? Suppose my car is running on the roadblocks, it automatically generates electricity. It will transfer into green hydrogen, small green hydrogen engines. What I also trying to make it myself, because I don't interest in a big engines, but small engines. Because I follow Manmohan Singh sir and Abdul Kalam sir, they always saying us small entrepreneurs can do extraordinary research because they know small things which is uh, suppose in case of solar industry we finding lot of difficulty in Canada, Europe countries because there are lot of snow. At that time, we make the parabolic solar panels. Parabolic solar panels. What happens? Suppose in Canada, lot of houses are parabolic type, pyramid type. So why we don't make the parabolic panels and we can generate the electricity? And parabolic panels can concentrate the photons from a surround area and we generate the lot of. And that's why we can make it commercially. Same like road blocks, we can make parabolic. And in case of green hydrogen, as per my opinion, it must be in every car, must be in every bike, must be in every houses within short time because it's a very cheap. You can generate suppose small engine. I am chemist. I know how to make the hydrolysis and how to make the oxygen and hydrogen different. But there is a risk is only blast. But small engines we can recover the risk. And that time we can use the roadblocks, solar tiles, solar panels. So that's where I go on research and I done a lot of research on that. And sometimes what happens, integrity. Suppose I make the integrity between instrument and solar energy. So what if you go only solar energy? Suppose I make only solar panel and go in the market, use market, but we cannot find out difficulty. We cannot find out how to use it and small applications like in the army we find out lot of applications. We find out in the industries some small motor different rpm is working. We can use it directly in solar. That's why. And second thing, lastly we after 5 to 10 years we make green hydrogen engines and we directly supply this solar industry to green hydrogen chambers. That's why I make the research. But my for the Europe countries, we are generally, I know Europe countries has a lot of snow most of years. But if you use solar energy integrating with the other alternate electricity, it must be very cheap. And if you find out particular application and connect with the solar industry, I know because in India, when I was coming 2006, per watt prices was 135 rupees, 140 rupees. But when we find out it's a proper application on grid system, it's a huge installing 2000, since 2015 in a giga scales. But even though lot of cars, lot of army vehicles, they don't in the outer area they don't have electricity. We combine with the solar energy as well as piezo, as well as roadblocks, as well as tiles, as well as flexible modules. Solar balloon we also make because what happens in a high-rise buildings we cannot get proper spaces for generating load because solar is a limitation. It cannot generate so much power. But we can take the balloons because government had given 50 meters area. Up to 50 meters we can blow the balloon and we get the electricity. That type of product I developed, and anyone want to know about my product, you can access my YouTube channel, you can take my website, and that's it. Thank you. I don't have
Thank you.
proper, but I can try to explain you all.
No, thank you so much, Mr. Patel. And just to your point, if there is any contact information you'd like to share, please feel free to put it in the chat. We did tag all of our speakers in the post we made about this webinar on our LinkedIn channel as well. So there's certainly opportunity for folks to get in touch. So thank you so much for your comments this morning. And I'd now like to move us on to our third speaker, who is Mr. Bhavesh Vathod, founder and director of Solios Energy Private Limited. Mr. Vathod is one of the leading figures in Indian serial entrepreneurship, currently holding positions as a managing director with Solios Solar, Ivy Capital, and Solios Finance. He has worked on an economically viable solar energy solution that was implemented across Gujarat's vast rural areas to thrive without reliance on costly fuel sources for electric power generation, while lowering pollution levels due to affordable, clean, renewable energy access everywhere. He is one of the emerging global thinkers who focus on the current topics and believes that educating the generations via blogs, video blogs, and articles from his social media platforms is of tremendous importance. Welcome to the webinar, Mr. Vathod. The floor is now yours.
Thank you, Anushka. It was really an honor, and you had given a beautiful introduction about me and the company. It is an amazing feeling when I'm discussing with you. I would like to discuss several things, and I would like to provide a little bit lights on how we can achieve the net zero when we say about industry or economics and everything, right? So first of all,
I'm sorry to interrupt, Mr. Vathod, but your camera is not on. I don't know if you had intended it to be on.
Home, so is it fine?
Oh, okay.
Hello?
Yeah, okay, go ahead. Sorry.
Okay. Because this is a late evening time, so almost everybody would be home. So I guess that's why I shut down my camera. So good to go?
Yes, yes,
Yeah,
Bhavesh, good to go.
Carry on.
Please.
Okay.
Bhavesh.
Great. So first of all, I would like to thank all the distinguished dignitaries, representative from the Government of India and Government of Alberta, and also fellow industry leaders and member of Alberta-India Chamber of Commerce. So now it is really an honor to be here today amongst all policymakers, researchers, and industrial fellows. Let me discuss about today's theme, which is capturing carbon and powering a net zero future together. So when we speak about the net zero future, it is less about technical ambition, and it is right now an economic necessity. So it is an opportunity for us to redesign how energy powers our society, our homes, our schools, our college, our industry, wherever we go. I represent Solios Energy, a company which is born in India and now expanding internationally with clear purpose to build reliable renewable energy infrastructure at scale and to make clean energy both investable and dependable. Now, when we speak about the net zero, we cannot be dependent on a single source. So rightly said by my fellow speaker, he said that, we require hydrogen and we require other sources as well. So, from coming from solar perspective, I would like to keep my focus related to solar and allied resources. So when we speak about the energy transition, so now the global conversation has shifted from why we should adopt clean energy to how fast we can deploy it and how reliably we can operate it. Solar has become the cheapest form of electricity. So if you have seen in recent tendering in India, if you say, or in UAE or in other countries, the rate of electricity has been significantly gone down when it is produced from solar energy. But there are several issues. The first and foremost issue is solar is intermittent in nature, or I would say any other, like if you go with wind or any other renewable energy resources, they are intermittent in nature. So by keeping that in mind, this intermittent nature of this renewable energy cannot help us to achieve net zero. So we require a stable power. And how we can achieve this stable power? So one option which was shown by my fellow speaker was the hydrogen, which was an amazing. But another one, hydrogen still seems a distant dream to everybody. because the technology is little bit complex. Adoption is also a little bit slow, and I don't know, right now there are less safety concerns, but in past there were very high safety concerns regarding that. So right now the handy technology which is available with all of us is called battery energy storage system. So now battery energy storage system has been evolved from just a battery. So when we say battery energy storage system, it is much more advanced version of just a small battery. Now let me tell you why this solar plus BESS is now backbone of industrial competitiveness. So the countries that can deliver low cost, reliable, clean energy will lead next industrial cycle. Now, if you'll see, wherever you are utilizing solar, you have abundant solar resources, but you need to utilize throughout the day and maybe sometime during the night time as well, right? So now from solar, it has become firm dispatch renewable energy or round the clock supply. So by using battery energy storage system, we can convert these renewable energy sources to a firm dispatch renewable energy. Wherever you need this energy, like from morning to evening or evening to morning, you can get this electricity whenever and wherever you require. Now there are other different versions are also available when you speak about the BESS. So BESS is not generally solar storage and utilization in the industry, but it can also help you to store your battery when your grid charges are lower. So we are working in different countries like US, we are working in European countries where they have different slots of energy. So in some slot energies are very cheap from the grid, and sometimes the energy is very costly. So you can do the arbitrage using this battery energy storage system itself. Other than that, you can utilize it to charge vehicles. You can utilize to work as an independent islanding system where you don't have any other sources. So this battery energy storage system will play a key and very vital role in wide scale industrial adoption of renewable energy when you speak about solar, wind, or other sources. So BESS is now key catalyst which will enable next generation revolution in adoption of renewable energy, right? So if we speak about the battery energy storage system a little bit more, so previously it was seen that BESS was very costly because lithium prices was very high. But if you see in last 3 years, the lithium prices has slashed down by 80%. So now the cost makes sense to everybody. So if any industries are there, or some consumer which is not industry, maybe some institution, they would like to utilize the solar energy or any other form of energy, but they have fear that they might run off, or this due to this intermittent nature of the energy, they can live without fear and they can have complete faith while adopting this renewable energy. Now since this is Alberta and India opportunity, previously we have been working with other governments of Canada in some research scale as well, and some adoption of commercialization as well. We have been trying to develop some RTC power plant in Canada. So I would say that now Alberta is sort of leader in energy infrastructure. They have huge workforce capabilities and they have industrial scale engineering. And India is one of the fastest growing renewable energy market in the world. So what I see right now is we have a beautiful platform for the collaboration where both the countries can collaborate and they can this increase adoption of renewable energy. And I have seen, in Canada, there are a lot of amazing research and development facilities available in the universities, in government funded programs. So exchange of this technology will also be useful to create and develop further manufacturing, further products for which will be helpful for both the countries in developing and in adopting the renewable energy much faster. So this was my take, and this was the message I would wanted to convey on this forum. Again, thank you very much for giving me the opportunity for this discussion.
Thank you so much, Mr. Prasad. That was great. Our fourth speaker is Ms. Neetu Prasad, Team Lead, Pipeline and Regulatory with Solaris MCI. Ms. Prasad has acquired more than 30 years in oil and gas engineering, consulting, and owner-operator companies. Currently, she heads the Pipeline and Regulatory Group in Solaris Management Consultants, and she has expertise in engineering design, project implementation, operations of upstream and downstream natural gas, blended oil, condensate and carbon dioxide, gas pipelines, and terminals. Her experiences range from designing, constructing, and working with large diameter cross-country pipelines to smaller distribution systems, thermal pipelines, and city area pipelines. Welcome to the webinar, Ms. Prasad. The floor is now yours. Kush, could we please get Ms. Prasad unmuted? Thank you.
Thank you. So yes, awesome to be connecting with everybody. And thank you, Anushka, for that beautiful introduction. I have had the pleasure of working in both Canada and India, almost more than 16 years actually in GAIL, Gas Authority. It used to be Gas Authority of India Limited, later GAIL. I've worked with other companies as well, like IPCL and EIL also over there. And here I've worked with Worley, which was also another engineering company. So we are hearing a lot about carbon capture and sequestration. And so today I was going to talk to you about carbon capture pipelines. Of course, everybody's talking about trying to capture carbon somehow from the process. If you have oil plants or upgraders or whatever, whether you are in the crude oil business, you want to capture carbon dioxide and you want to take it to a sequestration center, place where you would either utilize or sequester. Here in Alberta, there is a very big project that is in the pipelines, and it is for the pipelines, which is called the Pathways Pipeline Project. I've worked with that in the front-end engineering phase. It's still an ongoing project. It comprises of almost 1,000 kilometers of CO2 pipelines, which range from diameters of say 30 inches to 8 inches, depending upon whether it's the main trunk line or lateral line. And these essentially collect all CO2s, which are in the dense phase. So CO2 could be transported in the gas phase, but in order to get maximum amount of CO2 transported, you would like to transport it in the dense phase, which is like a liquid phase, a supercritical condition, and so very high pressures. Definitely higher than 8,500 kilopascals. You cannot have it below that. It has to be above that to stay in supercritical conditions. And so this pipeline that I was working with, like the Pathways pipeline, was in the range of 14,000 kilopascals. Various companies like CNRL, Cenovus, Suncor, all these big companies, 6 companies got together so that all the CO2 from their productions can be transported through these pipelines into an area. In Alberta, there's a place called Bonneville, where there are a lot of wells, like previously somebody was talking about whether they could be used up wells or new injection points, but that is the area that has been selected for all the carbon dioxide to be sequestered. Currently, this pipeline is not thinking of using the CO2, but yes, it's all being sequestered. So you have to look at which areas you can sequester your carbon dioxide in, what is the depth that you will take it to, so that they can be stored for a long duration without leakages. CO2 leakage is important because CO2 is asphyxiated. You have to transport CO2 in a very, very safe way. Now this, I'll get to that, but this Pathways Alliance is like proposing almost a 16.5 billion carbon capture and storage network in Alberta to reach a net zero emission by 2050. That's the target. And it is essentially going to do a lot for the oil patch here in northern Alberta, near Fort McMurray, etc. All these plants are near Fort McMurray, and this pipeline proposes to take CO2 from there and sequester. Like I was saying, we have already a couple of pipelines in Alberta, like the Quest and ACTL pipelines, which are also supported by the government of Alberta. These are smaller pipelines. The Pathways pipeline is definitely a huge, it's kind of a very large target that we are looking at, and a huge amount of carbon dioxide to be transported. The risks associated with a CO2 pipeline, they have all the risks that are associated with any pipeline. So whichever pipeline you build, there are risks associated with it. But CO2 has some additional things that one needs to look at. And that's one is, of course, the fracture control, because CO2, when there is a leakage, when there is a fracture, the fracture tends to carry forward to a very, very long distance, and it's very difficult to control that. So you have to take care of that it's not like natural gas or even oil pipelines. If the fracture is going to continue, it's going to continue for a very, very long distance. The gas is going to spread out, disperse, and you have to take care that this doesn't happen, because you have populations all around and you want to protect them. So it is it's an engineering challenge. A lot of research, testing, etc. is going on this. There's tests that you have to do for how the gas will decompress. There are tests that you have to do for the metallurgy, in which we are tying up with testing centers in UK, or like there are some test centers. Most of it, like DNV has one test center in UK where we carried out actual burst test of a pipeline to see how it would behave, so that for a particular pressure, for a particular flow rate, etc., and a composition, how it would behave and how would the burst happen, so that we can design the pipeline so that it doesn't burst. Like, we have a pipeline that will not fracture like it is known to fracture. So those are things that are still going on. And when anybody starts building these kinds of pipelines, these are things that they have to think from beforehand, because we do not have too much of data like other say if you wanted to build a natural gas pipeline, you have a lot of data for natural gas pipeline fracture control, but you don't have so much for CO2 pipelines. So those things are needing research at this stage. We are working on them, and we are getting success to some extent for, so large pipelines come with that. And of course, dispersion. That's another thing about CO2. How it disperses is also very important. Seemingly, it looks like, okay, what will CO2 do? It will not burn up. No, it won't, but it stays low, because it's heavy. So it's lower in the atmosphere when it dissipates. And when it does, you have very little time for what will happen with that. So it would be, if it's a very high percentage of CO2 where there are residences, it could lead to actual deaths. So you have to look at it in a different way than you look at many other natural gas pipelines. And so how you are going to control, how routing is essential, how you are going to route that pipeline so that you are risk-free is important. What kind of dispersion calculations you do from beforehand, again, that has also, there's lots of engineering and research that goes into that as well. So that's another area that one needs to work in. If I don't know how many of you would know, but sometimes you do a dispersion calculation and you say this is the radius. But what happens, the terrain also plays a part. So if you have, say you have a pipeline in an area and you thought this is the kilometer, say 2 kilometers around it, you will have a dispersion radius. But the gas, because it's it stays low in the atmosphere, it goes down into valleys. Like if you're up there somewhere, if there is a valley down there, this gas will flow down to the valley, which you had not thought of earlier. So there was an incident in Denbury in Zataria in the US, which gave us a lot of lessons on how we should look at these pipelines, because they had an emergency response zone defined based on calculations, but then they realized that this was at a higher level, and all the gas moved on to another a township where a lot of people had to be hospitalized because of this. So there are lots of learning opportunities in this as well. How the emergency response has to be going on, because in Denbury incident, there was an emergency response failure. So these are things we are having engineering design and experience here. In Alberta, I don't know how.
And Ms. Prasad, I'm sorry, we do have one more speaker. So can I just ask you if you could please wrap up in the next minute or so?
Yeah, sure. Thank you. Yeah, so that's about it. We have Deep Sky Alpha Hub in Innisfail, like that's Alberta government also encouraging a lot of CO2 direct from air capture, and that's one of the experiences that India could gain from as well, although they may already have work going on in those places. If you have any questions, do let me know. Thank you.
Thank you so much. And as a moderator, I always feel so terrible whenever I have to actually ask people to stop talking, because this is such an interesting subject. And I know there's so many fascinating developments happening in the sector, but I do want to make sure that we have time for everyone. So thank you for your patience with that. And with that, our final speaker today is Mr. Pratap Ayazpazim Vaigandasuba, a researcher at the University of Calgary. Mr. Subha is an electrochemist and a clean technology researcher with over 8 years of interdisciplinary experience spanning electrochemical systems, carbon capture and removal, and energy storage technologies. He holds a PhD in chemistry from the University of Calgary and is the CTO and co-founder of Peach Daiquiri Inc., where he leads the development of an all-electric, low-energy carbon dioxide removal technology that integrates flow battery principles with scalable industrial applications. He is committed to advancing practical, affordable carbon removal solutions that support Canada's transition to a low carbon economy. Welcome to the webinar, Mr. Subha. The floor is now yours, and I know that you had sent me some slides, so I am just going to start sharing those right as well.
Sure. Thank you for the kind introduction, and good morning and good evening all who are present here. So
Kushal, it is not working. I've got, Okay, I'm so sorry. I don't know why my sharing is not working here.
Yeah, it is working. He's there.
There it is. Can you see the black screen of slides?
No. Okay, your share screen is not working. Okay.
You can also just, yep, 1 sec.
Can you see that now?
yes,
Yeah.
Okay. Sorry about that.
no worries. Thank you everyone. So as I mentioned, I'm Pratap. So I'm a postdoctoral fellow in University of Calgary, and I am also doing this as the CTO and co-founder of this company. So here, my background research are in electrochemistry, and after joining University of Calgary, I did my PhD in flow batteries and specifically on aqueous batteries. So with that research, we transformed that how we can use that technology for modern problems to solve applications. So that way we moved into research for direct air capture. So I will give you a short overview of what we are doing and what's our next steps and all. So this information already discussed a lot here, but within Canada, Alberta is a leading energy generator, which means obviously it's going to be the leading emitter as well. So with over 270 megatons of carbon dioxide equivalent emitted per year. So within that, Alberta has its own pricing system, technology innovation and emission reduction. So within that, 24% of that Canada's emission falls under that, which means for this much, the industries that are running has to find other ways to remove this amount of carbon dioxide, or they have to be paying that. So the current problem is there are many technologies being studied and many technologies being implemented, but there is no commercially proven technology that has that is going to work in a long term, and that has to reach the gigatons of scale that we are talking about. So in that aspect, what we are trying to do is, can I have the next slide, please? So this is the same as I was talking. We are just trying to capture industries within Alberta. For example, oil and gas industries and mining industries. These are within the central Canada. These are main things. So whatever approach is, electrochemically, we capture the carbon dioxide, and the storage part we integrate with the saline waste from these industries, so that we reduce the cost of the end-to-end process. So I will give a short overview in my next slide how in general these technologies all work. So if in here, in general, whatever be the direct air capture technology, these three are the things. First thing we need to capture. So with that can be any kind of sorbent. It can be solid, liquid, CO2 being an acid gas. It's mostly a base that will be required for a capture medium. Then the second step where we regenerate the sorbent. That means we need to take back the pure carbon dioxide, and we need to regenerate the sorbent to go back to the next cycle of capture. And the captured pure carbon dioxide, it will be either sent to storage or utilization. So in here, the capture part itself, it's a costly one, and the regeneration, it's even more costly because CO2 strongly binds with any kind of adsorbent or absorbent. And in addition, there is storage. So on the whole, if you look at carbon, it's like an additional product out of our industrial thing. This is not our this is not what we expect to generate CO2. So as much as we reduce the cost, that's going to benefit us as well as the industry. So if you look at in the next slide, then the existing technologies that are being studied, it's like these are some of the things that are already being tested, like Climeworks and the carbon engineering. They are going to soon start their 500,000 tons of carbon removal. So if you look at all these, still there is thermal energy requirement, and even if it is completely electrochemical, their energy levels are too high because they spend energy both in the capture as well as the regeneration. So what we are trying to do is, what if we little bit tweak that technology in a way where we can reduce the energy requirement of the entire process. That's where what we are trying to use is, if we use a battery to regenerate the solvent, we will reduce more than half of the energy requirement. If we go to the next slide, where what we are trying is, we do the capture part as already in existing technology, and when it comes to the regeneration, we use the battery discharge reaction, meaning we are using alkaline solutions as electrolyte in a flow battery. When we capture it and discharge the solution, it will change the pH of the solution that will get out the pure carbon dioxide. So also our main intent is to have this technology as simple as possible and in a modular scale, like 1,000 tons of CO2 in that kind of scale. If we install it in a mining industry, so within there, they will have a lot of saline waste. So the storage part can also be integrated in the same place. So our major goal is to reduce the energy requirement, thereby reducing the cost, and have the end-to-end system installed at the industrial site. This is how we are trying to move this technology. So if I go to the next slide, please. So this slide, I made it here because this is some of the prototyping things that we are doing here. We started this research as early as 2020. Then we published our paper and a patent. So now I brought this slide specifically here because these stacked electrochemical cells, we custom designed it from India. So we are still working with them to replace this material of construction of this material is titanium. And we want to first show our end-to-end technology with a smaller scale in lab. And then we are also working on replacing the costlier materials with high density plastic materials to bring down the cost further. So if we go back to go to the next slide, please. So this is our team. I along with Aarti, and Aarti is also a PhD from IIT Hyderabad. We both are the prime researchers working on this project. And with Steve Larter, he has over many years of experience in carbon management and oil and gas related research. And as in this talk, there were many information about underground storage and basalt related research. Dr. Benjamin Tutelo is one of the leading researchers in that area. And we work with Nilesh Josier. He guides us how we can take this technology forward in a business way. That's how we are working. And if we move to the next slide, please. So as I mentioned, we started this as in 2021. Initially, we started this as an ocean alkalinity enhancement research. So meaning carbon, we capture it, we have to store it somewhere. So ocean is the largest carbon reservoir that exists as of now. So we still do research on this, but we are not yet there. But in the direct air capture stream, we have some better results. So we thought of first start something smaller and then at the same time improve this technology that can be later implemented in ocean alkalinity enhancement as well. We have a patent filed. It's currently patent pending, and we got some research grants, and we incorporated this as an Alberta incorporation in 2023. And currently we are trying to build prototype, and we talk to the industrial people how we need to adapt to how we can in future, how this can be leading to a successful business that benefits everyone. This is how we are trying to progress this research. And with that, we are a team of small researchers in here, but we are trying to solve this problem, and we are open to any collaborations or discussions on how these things can be taken forward. In that way, if anyone has any questions, always please feel free to email me. Thank you very much for this opportunity.
Great. Thank you so much, Mr. Sudha. That was fantastic. So with that, folks, and I'm sorry, I'm just trying to find my notes here. With that, we are done with the formal presentations for this morning's webinar. We do have just a few minutes if there are any questions. So if I could please ask if there are any questions, could you, okay, we do have one here in the chat. Question for Mr. Bimwal. Is India interested in other forms of hydrogen other than green? And then there's just some information about some discussion that she had had with the geological mapping. And we're speaking about DAC. I'm sorry, I'm not an industry expert, so I don't know what that is. But Mr. Bimal, if you're still on the line, can you please speak to whether or not India is looking at other forms of hydrogen? I don't.
Hello?
Yeah, Kishore.
Yes, go ahead.
Yeah. So, could you please repeat the question? Because I'm driving, sorry.
Is India interested in other forms of hydrogen other than green? I guess there's some, the person who's asking the question was speaking with the ONGC a few years ago. So wanted to ask for an update.
Yeah, thank you for this wonderful question. Actually, my core area is green hydrogen only. But I, choose this CCUS because now India is thinking to take a pause rather than jumping to green hydrogen, we have to take a pause on for the blue hydrogen. So obviously, yes, the answer is resounding yes. India is going to take a step on the blue hydrogen because, as you know, we cannot further rely more on the costlier technology. Rather than we should concentrate on our existing, coal reservoirs, maybe the fossils, so that blue hydrogen could play a beautiful role, I can say. So the answer is obviously yes. I'm ready to take further more question in this regard. Yes.
Great. Thank you so much for that. I am not seeing any other questions in the queue at this time. We are at 5 minutes to 9, and we do like to make sure that we keep things on track. So just before I wrap up with the preview of our next webinar and some closing comments, I'm going to invite Dr. Vandana Srivastava, the president of our forthcoming India operations, to please come on screen and just say a few words. So Dr. Vandana, go ahead.
Thank you, Anushka. Thank you, everyone, for sharing such valuable knowledge and highlighting the many areas where our two nations can work together. Thanks to Honorable Getson and His Excellency Masakoiji for all the support which they are giving all the times. My sincere thanks to Gaurav and Sanjay ji for bringing together such distinguished speakers. And I'm also deeply grateful to our speakers Pratap ji, Kishore ji, Bhavesh ji, Neetu ji, and Kishan ji for their insightful and inspiring contributions. And I'm pleased to share that His Excellency Patnaik sir will also be joining us virtually in our next webinar on 20th January. And the topic will be same, energy. So if you have any speakers who would like to participate, please share their details via email. And our email is like info@Alberta-India-CC.ca. And thanks Alberta-India Chamber of Commerce Canada team and India team for all their support. Thank you very much.
Fantastic. Thank you so much. And just for all of our participants, I have inputted into the chat both that general information inbox for any inquiries associated with the Chamber, as well as, again, the link to the YouTube channel where this recording will be posted shortly and all of our past webinars are already uploaded live. We, again, are very excited about the progress that we have made as a Chamber in the 4 short months that we have been in existence. One of the key services that we are looking to offer to members is that direct business matchmaking. So if you are interested, please do visit our website of Alberta-India-CC.ca. There are online options to register as a member from both Canada and India on the website, and we would love to facilitate those discussions. Yes, Dr. Vandana.
Yeah, from India also, if anybody wants to represent themselves in Indian Energy Week, so AICC is already there, so kindly give your name to us. We will be there, we can take your name, we can represent you, and we will send other info shortly on your email. Thank you.
Yes, we are very excited to have our first official delegation confirmed. So it's a pretty big milestone for an organization that's as new as we are. So we're very excited about all the progress that we've made. And thanks to all of you for the support and for coming to attend this webinar. Our next webinar is going to be Tuesday, January 20th. As Dr. Vandana said, it is also going to be focused on the energy sector as we lead up into India Energy Week at the end of that month. So thank you again to all of our speakers for the gifts of your time and your knowledge. It has been very enlightening to hear all of the discussions today. Thank you everyone for participating and for your questions. If you do have anything further, again, that info email address is posted into the chat. And we thank you very much for your attention. Wish you all a good day and a good evening. And we'll look forward to seeing you this time next month. Thank you very much.